Welcome to the presentation on the NeuroCom Clinical Research System. I'm Diane Risley. I'm a professor in the Department of Physical Therapy at Wingate University. I've been using NeuroCom systems for a long time, and I'm really pleased that you're here listening to this. Our objectives today are to introduce the clinical research system, to discuss the capabilities of the system in research applications, to discuss the interface, how to program it, discuss different ways to program, and then see the application in a sample research study. So the clinical research system combines the clinical balance testing and treatment for sensory and motor balance dysfunction with the ability to provide custom protocols for either the clinic or research. The clinical module provides all protocols and training capabilities as in the Smart EquiTest. The raw data can also be exported from the clinical protocols for analysis, and it does support a weight range of 40 to 440 pounds. The research module is different in that it allows the operator control. You have control over the platform and the visual surround, and over the data acquisition parameters. It has no standardized protocols or data analysis routines, and so this is something that you can program yourself based on what you want to determine. So if we go to settings in the module, so these are the settings that you can find. And the first thing is that there's header lines that you define as to what you want to see. And then I'm going to highlight a few of the other options. You can pick your language. Auto-save trials means that each trial is saved as you do it. You can also put in post-test comments, and then auto-export trials means that the trials are exported as you go through. The show trial review graphs is a review after every trial, and I'll demonstrate that later on. Zero load cells zeroes out the load cells every time you go to the main menu screen. And multi-group directory database management means that you can have different groups for your subjects. The file cabinet, if we go back, so we're going to save the settings, and then we're going to go back over here. And when we go to the research module, so this is the clinical module, and this is the research module. When we go to the research module, we come into the file cabinet. And this allows us to put in the subject's information. For research purposes, what I do is I use my identifier for the study in the last name, and the first name, the identifier of my subject. This allows me to sort when I go through and export files. Subject ID, I do let the system assign for me. You need to have the height in there and the date of birth. Even though we don't have normative data, it's good to have this information in there. There are different user-defined fields that you can put in, whether you want a diagnosis or whether they're control or experimental. You can have those in the user-defined fields. And then you can indicate an operator as well. And so we're going to go back to the file cabinet, and for today we're going to use our test subject and say yes. When we come to the main menu, we can state whether we want either dynamic or stable conditions. The dynamic conditions are on the EquiTest using this way reference conditions or the ramp conditions. Stable conditions are on the long force plate, so you can do the programmable on the long force plate as well. File cabinet returns us to the file cabinet screen. Export allows us to export the data that we collect. And then setup goes to setting up the trials. And so we're going to set up. A test, so you can choose a test, and a test consists of different conditions. The conditions are what you actually define. And then conditions have trials. So under the test, you can actually name the test, and I have one in here for the demonstration. And then you name each condition in this screen. And then you determine what you want the research system to do. The preset default test contains one condition and one trial. But any one that you do can have any number of conditions and any number of trials. So the trial duration is set between 1 and 600 seconds. The default is 30 seconds. So in this one here, I've actually changed the trial duration to 12 seconds. We then can set the number of trials for each condition. These trials occur consecutively, and so they're the number of trials with the exact same settings. Conditions is where you put different settings. The output sync pulse allows us to use a trigger pulse to trigger the, and that's here, to trigger the study or trigger the condition. So you can do the sync pulse and you can have it either initial low, active high, or initial high, active low. For the trial definition, you can have a show cursor and show trace, and that the subject would see if you have the screen in the surround turned on. This doesn't apply to pre-testing, as the cursor is always shown. The test trigger end means that a trigger ends the test by a certain state of the initiating trigger. If weight is selected, the trial ends when the weight on the platform is below the specified threshold. If it's not selected, the trial ends after the time. We also have accessory channels so that you can do things like EMG with the study. Collect sync line status data will result in sync line data collection. It reflects the state of the in and out switch box, which is over here. The collect precision 3 degrees of freedom data, which is here, allows you to collect data from the head tracker system. And so it gives you the subject's yaw, pitch, and roll movement of the head in addition to center of force and center of pressure information. But because you can take the sensor off the head-mounted display, you can actually put it on any body part and detect the movement of the body parts itself. And then we have randomizing the conditions. This randomizes the conditions themselves and not the trials. So within each condition, the number of trials that you specify are going to occur sequentially. But each condition can be randomized as you go, so you can do a randomized condition, but not trials. If you put on here the test trigger as a mouse click, then you're going to click on the mouse to start it. If it's weight, then the trial is going to start when the weight detected on the platform equals or exceeds the weight indicated. So on here you would put a threshold. You can do this for things like step if you want to. So with this one, I want mouse click. Sync pulse is used when you have the signal state change is detected on the master inline switch. If it's selected, a signal state change on the master inline will terminate the test. So for the motor modes, we have 3 motors. There's rotate, translate, and visual. Rotate, the platform is rotating either in an anterior posterior or a medial lateral sway if you have the person turned to the side. Translation is forward and backwards, and visual is the visual surround moving. Each motor will support 1 of 3 test modes. Fixed, where nothing moves. It can be sway, which is sway referenced. It can be ramp, where there's a single ramp movement, or you can put in a waveform, and I'll show that in a little bit. Sway referenced the selected motor movements will follow the subject's center of gravity. So as the center of gravity moves, the surround or the platform moves in relationship to them. You can adjust the gain of the sway referencing. A gain of 1 is what you have in the clinical protocols, but you can change this from -2 to 2 so that the movement of the platform or the surround can be twice as much as the person moves, or it can be in the opposite direction if it's a negative. Put that back to ramp. With ramp, you have a start position and an end position. You have ramp time and then the delay of the ramp. These are some of the components of the range and direction, maximum velocity, excursion, and position error of rotation, translation, and the visual surround. So I talked about the ramp time. This is how long it's going to take to do the actual ramp, which means that you're going to look at the start position and the end position and look at the difference between the two, and that's going to occur over the ramp time. The velocity, and that gives you the velocity. Ramp delay is how long it's going to take before the ramp occurs. It can range from 0 to the duration of the ramp time. Sync pulse trigger initiates a preset motor profile by detecting the change on the corresponding motor input. If waveform is selected, you're actually going to get a setup box. And if it's been associated before, it will display on the screen. And so what I'm going to do is go to a condition in which I have used a waveform and show you what the waveform looks like. There we go. And so because I've set it up, I have the waveform on the screen. To set it up, I can go in and give it a function. I can do a user file or a script file, and I will show them in a minute. It recognizes most mathematical functions, but you need to have it a function of t. The graph conforms to the amplitude specified for each motor. However, you can go to a full scale function right here, which would fill the full screen. And then it shows here as well. To use the user-specified files, there's two formats. Format 1 is an interval between data points that's indicated by variable dt in milliseconds and must be a multiple of 10. And so if dt equals 1,000, each data point is separated by 1,000 milliseconds. The maximum dt is 10 milliseconds. You have a data delimiter that has to be specified between parentheses. This is an example of the user-specified data files. And so example 1, you have the dt equals 1,000, the delimiter being a comma, and then it gives the position of the motors. The second way is just to list them in a line, so in a column. And again, this indicates the position of the motors. So if the total numbers posted are multiplied by dt exceeds the trial duration specified, it will stop, and the later data points will be omitted. The waveform will be rejected if it exceeds the motor performance, which was indicated in the previous slide. And finest movements are generated by setting the dt value to the minimum of 10 milliseconds. You can have a multi-jog. For smooth-like movements, you're going to define the high resolution of the motor positions in small dt, and multi-ramp is for fast ramp-like movements. And you're going to specify low resolution of the motor positions and a large dt. Format 2 is a time interval between data points is specified by dt equals question mark, which signifies variable time. And the initial starting amplitude of each motor is specified by ST. And what this does is you see this formatted as a target amplitude and the time to achieve that amplitude. And so you specify it by different times. It doesn't have to be an equal time between movements. So script files are, again, user identified. And when you hit a script file, run script, it's going to come up to your screen where you can choose the different files. And so I can actually choose a ramp script file or a user file, however I have it defined. And I will show you those in a minute. So I'm going to cancel this out because I have different ones on there. It is custom motion profiles, and it supports two functions, delta time and add data points. The user specified script files, this is an example where you actually will be indicating these different parameters, and then you can tell it from a certain time what you want it to do, and then for the next time what you want it to do. And this is by waveform functions. So it's really defined for the person. And so if we look back here, let me go back to my conditions. And what I want to show you are a couple scripts. And so this is one where if we look here, I have had a script on here. And so this shows you that at different times I have different waveforms. And you can do it from any of them. I will show you these later. For data export, so now that we've collected the data, and to collect the data, all I'm going to do is hit continue. And for this one, it's going to use the head tracker. And so I'm going to initialize the head tracker. And then it comes up to the condition. And this is a 1 degree per second ramp. And it tells me over here what it's going to do. It shows me the timer and then the grid where I'm going to see the cursor. At this point, I also can say show the reference point or auto advanced conditions. So if I start it, this is telling me the position of the head tracker. And I'm going to be able to follow that as I go through the trial. And because I've put it on the head, I'm a little bit off on yaw. I can actually reset zeros so that I know that it's starting straight. And then I'm going to click any button to start collecting the data. Right now I don't have anyone up on the platform, so it's not giving me the cursor. And then I can stop it. It immediately shows me what the platform has done and then I can also see center of gravity, center of force, and then the two together. And like I said, I don't have anyone up there, so I didn't get any of those. It then immediately goes to the next trial, next condition. And so this would be a 2 degree per second ramp. But now that I've collected data, let's go back to export. And so to export, I'm actually going to go back to the main menu and go to export. And this brings out binary files that are collected with the software into a text file. So if we select the data export button from the main screen, we get all of the subjects that have been tested. And we're going to go and hit our test subject. But first we're going to go to options. And options tell us we can indicate what motor position we want, whether in inches or in centimeters, in counts or distance. We can look at the load cells and again, forces and moments and what units we want them in. We can look at center of force, center of gravity, our accessory channels, and the 3 degrees of freedom data from the head tracker. This gives us our decimal precision and what delimiter we have when we pull the data out. We can also indicate that we export the test settings and the universal format. The other thing is this is all going to be set usually when you begin, and then because you know what parameters you want. The file types, you may do one of two things. You can get one data file for all trials, and so batch settings, and then one data file per trial. You can also indicate what information you want for each of those trials. Then I'm going to save it, go back to the export screen. And then once we have all those parameters selected, we're going to come up to our subject and then hit export. I'm going to define an export directory, and I can browse and set up a new one if I want. So right now it's under the balance research data and an export file. But you can set up a new file if you want that going somewhere else, like for a specific patient or a specific study. So I'm going to say OK for this one. And now it's actually exporting all of the data for that subject, which we've used that subject a lot, so we have a lot. So I'm opening the directory. So we're going to go in and we're going to pull up this, this trial that we just did. And what we're going to see is you're going to see these headers where it gives us the version that was collected, the date, the time, and then it's going to give us information on the subject, the user-defined fields, and then the test type and the condition. And so this, we actually did a fast rotation and translation ramp that I will show you a little bit later. And what we get in this is a text file, and we get the rotation and the translation. Rotation is always in degrees, translation in inches, or actually you've set that up when we did the options. Then you're going to get the force plate, the left and the right, Fx, Fy, and Fz, as well as the moments for X, Y, and Z. And then we're going to get the same things for the right force plate, so you can look at each foot and their function differently. And then if we keep scrolling over, we get center of force for X, center of force for Y, for the left and for the right, and then we get it combined. We get center of force and then center of gravity combined for X and for Y. So what we can do, and I'm going to demonstrate this a little bit later, is we can pull this data into Excel and we can run calculations like velocity, acceleration. We can look at the positions. And so you can actually use this raw data to calculate and then form the answers to the questions you're trying to answer. You can also pull it into MATLAB and have MATLAB do the calculations as well. So I'm going to close that out. And so that's the trial that we would get. These are the rest of the settings just listed. And then what we see based on in those text files. Now, the platform coordinate system, remember that it has two independent AMTI force plates. And each force plate measures 3 forces and 3 moments. So 3 forces being Fx, Fy, and Fz, and the moments being Mx, My, and Mz. The origins are at the center of the force plate, and that uses a standard Cartesian coordinate system, so that positive Y is facing forward, positive X is in the right-hand direction, and remember that Z is the vertical movement. So when facing this around, the left force plate is on your left and the right force plate is on your right. Now we're going to go back to the data file that we just looked at and show you how to do a simple analysis. And so I'm going to come here and choose this file. And you see that it comes up in the text file that we saw on the other computer. So now what I'm going to do is pull it into Excel. And what I do is I'm going to come into Excel and I'm going to go open and I'm going to browse. And when I browse, I'm going to go back and find the folder in which it's located. And you'll see that no items match my search because I'm searching for Excel files. So I need to go and search for all files. Then I can pull up this file. Now here it asks me whether it's delimited or fixed width. It is delimited, so I'm going to say next. And it's delimited by space, so I'm going to indicate by space. If you've indicated either comma, quotation mark, whatever during your programming, then you'll include that here. If I scroll down, then you actually see that everything is in columns. So I'm then going to hit next and finish, and the data comes up in the columns in which it was collected and analyzed by the computer. The next thing I'm going to do is I'm actually going to highlight all of this top information that talks about what was done with the data. And I'm going to copy that, or actually cut that, and I'm going to put it into another sheet. And I can label that patient information or trial information. But what it allows, once I clean up this, then I can actually get rid of these rows, and now I have a nice database from which to work. And you can see all the information along here. Now, if I want to calculate something like velocity, I can do that over here. And so if I want to calculate velocity, I can put in the formula of, and if I want to look at the center of force in the y direction, I would put equals U5 minus U3 divided by 0.02. And so, and the first cell is going to be 0. And then what I'm going to do is I'm going to copy this and I'm going to paste it into the other blocks so that the formula is all the way down. And so then I'm going to, I can either do Control V and put it in, or I can do the right click. So now I have the velocity all the way down. And then if I want to get the mean velocity, I'm actually going to do the absolute value so that I don't cancel each other out when they're going forward and back. So I'm going to do the absolute value of each of the velocities. So for this, I'll do equal absolute value, and then I do x4 and enter. And I'm going to enter that all the way down as well, and then I can do an average velocity. I can also chart these and plot them out. And so if I wanted to look at the velocity, I can actually make that into a chart. And now I can see that when the platforms move, you can see the velocity of this. And I can actually look at the platform movement here in the beginning. And so I can judge this against the platform movement and see where the platform moves and the person moves. I can also do these graphs for any of the center of force, center of gravity, and be able to compare them. So what we're going to do now is demonstrate some of the capabilities of the motors. And so this first condition, we're going to see rotation and sway. We're going to see a waveform for the translation, and we're going to see a ramp for the visual surround. Are you ready? Okay. And I'm going to zero. We're using the head tracker. So I'm going to zero out the head tracker so we know where his position is. And then I'm going to go ahead and start. And so right now he's got translation in a waveform. He's got rotation at the, and then he just had a ramp of the surround. And here you can see the motors. This is the visual surround. You can see the ramp. Then if I click on translate, you can see the waveform. And for rotation, you can see the sway referencing. You can also on this screen, I can see his center of gravity in the XY, and he stayed pretty steady. I can see center of force, and I can see them both. Can also see the motor position, as well as the center of gravity in the X and the Y positions. So it gives you an idea of how somebody is moving even before you analyze the data. So the next condition, we're going to do something a little bit different. We have it set to start on sync pulse trigger, and then the visual system is going to go into sway referencing. The ramp rotation is going to occur when I tell it to, using the trigger on the input-output box. And so are you ready? And so it's waiting for the sync pulse trigger to actually start. So I'm going to start the sway referencing, and now I'm going to give it the rotation. And I could do that at the point when I felt he was most unstable, or depending on where in his sway path I thought it was best. The next condition we're going to do is just a ramp rotation. And this is a fast ramp rotation, but it's one that I have used in my research looking at how the brain uses sensory information for balance. You ready, Trent? And this one again uses the head tracker. So I'm going to reset the zeros, and then he's ready to be tested. And so there's a delay, and then both the visual surround and the rotation were moved in ramp. In the next condition, I'm going to have him stand in a stance position so that one foot is in front of the other. So Trent, if you can step your left foot back, that's good, your right foot forward, but stay on the platform. That's good. So this is going to show us that the center of force on the left force plate may be different than the center of force on the right force plate, and I may want to look at them differently. And what we're going to see is a ramp translation with him in this position. So almost like simulating a slip that would go to a fall. You ready? And again, we have a 4-second delay. And so you can see that it actually did perturb him, and there was probably some differences in weight distribution. In this graph, I cannot isolate the left and the right force plates, but I can do that in the data. The next condition is just a rotation sine wave. And so this may be something, again, that you choose to look at what the sway pattern is. And now I'm going to bring him back to a normal stance. Notice that I am not using I don't have to use the foot position that is used in the clinical setting, the clinical system. I can choose whatever foot position I want because we're not looking at normative data, we're looking at research data. The other thing to look at is that he's wearing non-skid socks, and that is how the protocol has been developed. However, in research, you may want to use bare feet, and that is fine as long as you're cleaning the platform in between patients or subjects. You ready? And here we go. So this is just a rotation with a waveform. And I'm not going to run the whole 30 seconds. Okay, this next one is a script file. And so what it's going to show you is we can do different waveforms within one trial. You ready? And so if you look at the force plate, you can see that it's running different waveforms. Now it's going to go faster, and then it'll go a little bit faster. And I can show you in the next screen the different waveforms that it's using. Good. And so if we look at this next screen, you can actually see the differences in the waveforms as it goes through the trial. This next one is a user file. And so what you're going to see is that we can do more dramatic changes using a user file. And so this is in translation. You ready? And so this is a little bit harder to see in translation, but you can see that the platform is not just going in a sinusoidal pattern. It has different velocities and different ramps during each one, or in each part of the trial. And again, we're going to be able to see what this looks like using this screen. And so again, you can see the dramatic changes that were able to be programmed using this. The next is another user file, and this time it is doing rotation. And so here he goes. And so you can make these user files either very smooth or more abrupt. And depending on what what questions you're trying to answer in your study. So this one, again, gave more abrupt changes. We're going to be able to see it here on the graph. And on these graphs, what we have is what's programmed in the green and what the motors did in the red. And so it's not always exact because it only does what the motor capabilities are. All right, this next one, we're doing a faster rotation, and we have the rotation and translation moving in opposite directions. Are you ready? Again, we have the head tracker on, so we're going to reset the zeros. And if you look at the tracings in the center, you can actually see how unstable he was in the beginning, and then he was able to become more stable with the procedure. You also can see on this how much head movement he has. And if you see, he's actually going into a little bit of pitch to try and help to control his balance. And again, we can look at the motors for both translation and for rotation. So this next condition uses a user file, and I want to show you a couple different options that you have. If you look at waveform setup, you have either a multi-ramp or a multi-jog option. Multi-ramp really considers velocity before position. What it means is it's going to take into account the acceleration needed and make sure that the motors are in a position to get that velocity you're asking for, even if it has to push it out a little bit. Multi-jog takes into account position and is going to hold the position still, or accurate. And so it's going to be a smoother movement. So let me show you this one in multi-ramp. And so I have to go to condition 14. All right, so let's do this in multi-ramp. You okay, Trent? Okay, and here we go. And where we're really going to see this is when we look at the motors, all right? But it may be more important to your research to have it really smooth or to have it really fast and accurate to velocities. And so they've actually given a really nice capability with this. And so I'm going to stop him at this point. And if we look at the motors, what we see with this is what we saw earlier, in that the position of the motors and the position of the center of gravity, they're shifted. And up here, I can get this where I want it, you can see that it maintains the velocity, though it shifted the position. But let's go back through and see what it looks like with multi-jog. And so I'm going to go back to the settings. And then what I'm going to do is go back to waveform, pick multi-jog, and then I'm going to save the settings and go to that trial, and we'll see what it looks like. Okay. I'm almost there. 2. All right, let's see what this looks like. You ready, Trent? So it's hard to tell while he's on it that there's a lot of change. But if you had seen the platform, it looks a little smoother at this point. And I'll show you when we get to the motors that it's smoothed out. So let me go ahead and stop it again. And now you see that it's on, the motors and the position are actually right on top of each other. And so it's really kept to being true to the position, even though it has to sacrifice a little bit of the velocity. This last one is a fast rotation and a ramp translation. It's actually designed to make him unstable and to see whether he can learn to maintain the perturbation. We're looking at doing this possibly with high-level athletes. And so, are you ready? Okay. And this time he has a target. I want you to try and stay in the target. And so you're going to see how hard it is to stay in the target. You ready? Again, there's a delay of about 8 seconds. And it actually made him step. Okay. And I'm going to stop it because he did step off, and for safety's sake, I want to make sure he's not where it moves, the corners where it's moving when I reset it. Okay, so he stepped back on. But you can see how abrupt that ramp rotation was. All right, so those are some conditions and some different things you can do with the system. I encourage you to play with it and see what the capabilities are.